Hi everyone. This video is talking about clipper circuits, and so there's two circuits on the screen. They're different, and let's take a look at the top circuit and see what are the components of this circuit. We have an AC power source, we have a resistor, we have a regular diode. Okay, so this is not a Zener diode, it's a regular diode, and it's connected in such a way that it is forward biased during the positive cycle, and we have a load resistor in parallel with that diode. So the voltage across this load resistor, which is going to be our V out, is going to be the voltage across that diode. Okay, that's very important. So let's look at the circuit operation. So remember, our V out is this voltage across the load resistor, which is the same as the voltage across this diode. Now, to analyze this circuit, we want to look at what happens during both the positive and negative cycles. So in the positive cycle, the direction of the polarity across the power supply is going to be like so. This is going to forward bias the diode. Okay, so when it's forward biased, we know that the diode will be on if that supply voltage gets above the 0.7 volt voltage of the diode, right? The forward bias diode. So once it does, the output here is going to be limited to that 0.7 volts once this diode is on, right? And that's why for the positive cycle, you see that it gets limited. It rises up till it hits that 0.7 and then it gets limited there, okay? For the negative cycle, the polarity across the power supply is in reverse, and same with the diode. So in that case, the diode is reverse biased, which means that the diode itself is off, and the current will actually flow through the load resistor and back around. We still have current flow. However, this diode is off. When the diode is off in reverse bias like this, the voltage across it is whatever voltage would be across that load resistor in analyzing that circuit. It's going to have the same shape as that negative cycle, and so that gets passed on. Okay, so let's look at that same thing for the second circuit. Now, the difference between the two circuits is, in the second circuit, the diode is flipped around. Okay, so now the diode is going to be forward biased during the negative cycle. And so what happens there is, for the positive cycle, the diode is actually reverse biased, which means the diode is off, so it's acting like an open circuit there, and our output voltage across RL follows the shape of the positive cycle. The amplitude will be different because some voltage will be dropped across that resistor, but right now we're just looking at the shape, not exact values. For the negative cycle, the polarity is like so, which forward biases this diode if this drops below minus 0.7. And when it does, this diode will be forward biased with a polarity like this, which means the voltage here will be minus 0.7 volts with reference to this ground. Okay, because this side is going to be more negative than that side. So our output is like so. Okay,